Try this one first. Solve 2 to the 2x plus 1 equals 3 to the 3x minus 4. This is when we can't make common base. We have two exponents. We log base 10 both sides. We agree? We have to be able to see and spot and do. So we're going to have log base 10 of 2, 2x plus 1, equals log base 10 of 3 to the 3x minus 4. The next step is to drop it in front and put it in brackets by using the power rule. So 2x plus 1 log base 10 of 2 equals 3x minus 4 log base 10 of 3. Then we distribute. 2x log base 10 of 2 plus log base 10 of 2, or 1 log base 10 of 2, equals 3x log base 10 of 3 minus 4 log base 10 of 3. X is to one side, so 2x log base 10 of 2 minus 3x log base 10 of 3 equals negative 4 log base 10 of 3 minus log base 10 of 2. Take out an x. We're left with 2 log base 10 of 2 minus 3 log base 10 of 3. This just stays the same. And then we divide by 2 log base 10 of 2 minus 3 log base 10 of 3. They say for exact values you could just leave it like this. But to the nearest hundredth, what did you get? 2.66? All right. What happens if I put a number in front, though? I didn't do this when we did this question because I wanted you to practice a few of these and get it down pat before we added one little extra step. So there's two ones that we could get. I could give you two that you can't make common base, two exponents, log base on both sides. Correct? The next one, I'm going to get you to solve, and we can start this one because it's the one people forget how to do. What I can do is I can give you the same question, 2 to the x plus 1 equals 3 to the x minus 4. How is it different? They'll do this. They'll add a number in front. Now, this can go wrong real quick. Some people will just write 8 to the 2x plus 1. You're immediately done. I don't even have to mark anything. It's the easiest marking question, saddest marking question. They go hand in hand. If you make it be 8 to the 2x plus 1, you did illegal math, you're done. The whole question, you're done, as they would say. Now, why? Because the 2 is to an exponent, correct? And I told you we can't do that. Now, how did we get rid of the 4 before? We would divide it over, yes? Problem is, what's on the right-hand side? A base with an exponent. You're not making your life any better. You can't write 3/4 to the 3x minus 4. That's also illegal. So you can't move that 4 to make it pretty. There's no movement. So you still do the exact same steps. You log base 10 both sides. There's just an extra step in there. It's in the second step. If you log base 10 both sides immediately and do the second step correctly, this whole thing will be done perfect. Okay? It's just a catch on the second step. So we log base 10 both sides. I can't move the 4 over. It ain't going to be pretty. I can't move the 4 into the 2. Isn't going to work. Okay? So I just log base 10 both sides, even when I see this. Log base 10. Now what I'm going to specifically do here to catch myself is I'm going to go 4 dot. Why do I put a dot? Multiply. To make you realize, hey, I'm multiplying. And remember when we put dots in there, hey, I'm multiplying, I could separate them by addition. Correct? So I'm putting that dot in there to scream separate by addition. So this is the first step. I get 2 to the 2x plus 1. These are multiplied. Equals log base 10 of 3 to the 3x minus 4. So that's the first step. Now here's the catch. Do your second step right, the whole thing will be done right. Your second step wrong, things go badly. So these two are being multiplied, correct? So my second step is to separate them with addition. That's it. If you do that, you just do the rest all the same. So I have to remember my second step. My second step, this is the hard one. This is the part where everyone screws up. Well, first off, people will put this together and make it an 8, and I'm just like the saddest marker ever. Okay? We get past that, this is the spot where people make mistakes. So we're going to get log base 10 of 4 plus log base 10 of 2 to the 2x plus 1. And the reason why I can separate them by addition is that product rule. Remember I told you if you have two things multiplied, you can separate them by addition? Equals log base 10 of 3. And now we do every step the exact same as what we did before. So we just have this extra step in step 2. Now what did we do in the previous question? Took our exponents and dropped them in front, right? We're going to do the same thing. This log base 10 of 4 is just going to go along for the ride. So we get log base 10 of 4 plus 2x plus 1. These are going to drop in front. Log base 10 of 2. You just end up with an extra log along for the ride. What was our next step after we did that? Distribute. So there's literally one extra step. That's it. You see it? Step 2. You can get step 2 right, you can get the rest of the question right. That's, of course, if you can do the previous question. So we get log base 10 of 4 plus 2x log base 10 of 2 plus 1 log base 10 of 2 equals 3x log base 10 of 3 minus 4 log base 10 of 3. Why can I give you these questions just randomly out of my head and you don't need an answer key? What could you do to the original? y1, y2 and get an answer. You don't need an answer key. You need to just type y1, y2, get an answer, and then you'd know if you're right or not, right? I don't need to give you the back of the book. Okay, what was my next step after I distributed?
Move the x's to one side.
Move the x to one side, everything without an x to the other side. So I'm going to subtract log base 10 of 4 and subtract log base 10 of 2. And then I'm going to subtract 2x log base 10 of 2. What am I doing? I'm going to subtract the 3x over to the left. I don't even, my brain just went into autopilot, but not good autopilot, bad autopilot. Like crashing autopilot. I would have moved everything to one side. That would have been stupid. Okay. So I'm left with 2x log base 10 of 2 minus 3x log base 10 of 3 equals negative 4 log base 10 of 3 minus log base 10 of 4 minus log base 10 of 2. What's my next step? Take out a GCF of x. Is there anything different except for example 2 or except for step 2? No, step 2 is the only thing different. So you can get past step 2 and you can do the previous question, you can do this question, right? Take out an x. 2 log base 10 of 2 minus 3 log base 10 of 3 equals negative 4 log base 10 of 3. Remember, you can type these in without the log base 10, right? You can just press the log button because it is base 10. And make sure You're typing it all at once, numerator in brackets, denominator in brackets. You're not using the fraction button. You guys type it in? Did anyone type it in? What do you get? 3.4. 3.4? Did you get 3.4? Riley, did you get 3.4? Did you type it in? She's double checking her typing. What are you guys getting? 3.42? Happy? I just need 2 people to say yes and we'll go. Okay. Now remember, you can y1, y2, and y1, y2, you can check it, right? Okay, I'm going to give you an example that you're going to try. I'm going to give you about 3 minutes to try it. I am not going to go through the answer. Why am I not? Because you can y1, y2 and check it. Exactly. Okay, here's your question. Then we're moving on to log graphs. So solve 3, 3, and then 4 to the x plus 1 equals 2 to the 2x plus 1. And go. We are going to look at an exponential graph first before we look at a log graph, and you'll see why. So we're going to look at our base, one of our base functions. I'm going to look at y equals 2 to the x. So this is logarithmic graphs. You might be like, well, that's an exponential, you dummy. Yep, I get it. But logarithmic graphs, you'll see where the connection is. So we're going to look at y equals 2 to the x. That's your base parent function of a doubling equation, right? Because our r is 2. And our initial would be 1. I could write this as y equals 1, 2 to the x. Bless you. I could write it as the same. Now we know that this function has a what asymptote? Let's pretend that's terrible. I can't even pretend that's straight. It's just awful. I'm going to use it has a horizontal tangent. Exactly. But where is it on this specific one? It's on which 0? Yeah. It's on the x-axis because it's a horizontal tangent, and the actual equation of the x-axis is y equals 0. And how do we know? Because it's based off of our vertical translation, right? Our vertical translation is the only thing that can move that asymptote. We agree? Yes. So it's on y equals 0, which is true. Okay? We also know this is an increasing function. Why is it increasing? Because there's not a negative in front. And we know that if it's doubling, it's increasing, correct? Every time it's doubling, 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 doubling. So if my b value is between 0 and 1, it's halving, quartering. It's decreasing function, right? But this one is doubling. So anything when my b value is over 1, it's actually increasing. So this function just goes through like 0, 1, and it runs along like this. Now, obviously, this is the most accurate graph you've ever seen because I took one point and then sketched it how I felt it would look. 100%. Perfect graph ever. Is that really actually how I want you to sketch graphs? I have told you that no, I do not. The good thing about it is it doesn't look like I drew it while on a bus going over a speed bump, so it's straightish. But I have one coordinate, which is not good. You all giggle, but half of you drew it without coordinates in previous graphs. So what we're going to do is we have a calculator. It's worth lots of money. We can do second trace value, and we can put in like -4, -3, -2, -1, 1, 0. We can put in 0.5, -0.5, right? We can put in all these values. We could go second graph. We can pull values off of it. We agree? So let's do that. We're going to get more than what I just sketched because I gave you one coordinate, which is extremely not accurate. And I'll show you why we care. So we're going to go 2 to the power of x and then second table. Or just second table. Why is mine not moving? Okay, so I basically have, I'm going to make myself a little table. We're going to see why I make this table. So I'm going to go x, y, and I'm going to start -4, -5, whatever. I have -5, and I have, this is for y equals 2 to the x. And I have 0.03125. Then -4, I have 0.0625. -3, 0.125. -2, 0.25. -1, 0.5. 0 is 1. Ooh, there's my 1 coordinate. Big old 1 coordinate I used to sketch this graph. 1 and 2, 2 and 4, 3 and 8, 4 and 16, and I've run out of graph, right? But those are way more coordinates than when I sketched. So I'm going to go back and attempt to erase my horrifically drawn graph. Okay. Now, does the scale have to stay as a 1? If leaving the scale as a 1 gets me 1 coordinate, should I leave it as a 1? No. If majority of my graph, because I left it at a scale of 1, is drawn off of the actual graph and over the writing of the question, is that a good idea? That's a bad idea. That will give you bad marks. Okay? Change your scale if you need to. This one we don't have to. I can go -5 and 0.1, 2, 3, 4, 5. So very close to the x-axis. -0.0, very close. 0.125, still very close. 0.25 is a quarter, still close. 0.5 is getting a little better. Then I have my 1. Then I have 1 and 2. And then I have 2 and 4. And then I have 3 and 8. And then I should just let them assume it's 1. No. I should label all of them with really tiny numbers. No. I can just write my scale, right? So I can say x scale equals 1, y scale equals 1. Then I don't put all little ticks, but you can put the numbers on if you want. So it's running along here, and then it's curving up. I was actually kind of relatively kind of close. You guys not always so much. Okay, so we're going to make it accurate. We agree? What's my domain? X and L are the reals. I can do a side-by-side comparison here. I'm not going to be able to, but. Or -infinity to infinity. And what's my range? Not equal to, correct? What makes it flip? A reflection in the x-axis. So a negative with the y would make a range change. Negative with the y would make a range change. Okay, why the heck would I talk about an exponential function?
I don't know why you did that to yourself.
Because the inverse of an exponential is a logarithm.
What now?
So, let's look at it. So we know we have y equals 2 to the x. That's what I gave you. We agree? And I just told you that an exponential inverse is a logarithm. Conversely, a logarithm is an inverse of an exponential. What do we know when we have inverse graphs? Your x's and y's switch, and there's a reflection on the identity line, which is the line y equals x, because when you have invariant points, it means that they will stay the same. If your x's and y's are the same and you flip them, you have the same point. Like 2, 2 becomes 2, 2. 1.2 and 1.2 becomes 1.2 and 1.2. So if I want to get the equation of an inverse, what's the very first step? Yeah. Switch your x and y. So we don't move anything. We just y becomes x, and x becomes y. Kind of hard to graph when your y is in the exponent. And by kind of hard, I mean you'd have to make a table of values. Other than that, you wouldn't know what to do, right? But what did I tell you when you find the inverse of something? You swap the x's and y's and then get y by itself. That's my rules, correct? I have a y sitting in an exponent.
Log it.
I'm going to have to change it to a log, because the only way you can get your exponent to drop down is converting it to a logarithm, right? Whenever we want an exponent to come down, we have to convert it to a log. So let's see what we get. So I get log. The base of my exponent becomes the base of my log. 2. What goes beside it?
Yes.
The x, because what's friends doesn't stay friends, right? And what does it equal? The exponent, which is the point of it all. The point is to get the y to come down, correct? The point is to get your exponent to drop down. So now I have y equals log base 2 of x. And I can sketch it really easily without using my calculator, because I have all these x's and y's. And what's going to happen to all these x's and y's? They're just going to flip. So what's going to happen to my horizontal asymptote on an exponential? What's going to happen to my log? Instead of it being a horizontal asymptote, it's now going to be a vertical. And instead of it being above, unless there's a reflection, it's going to be to the right. And if there's a reflection, it'll be to the left. Wait, my domain of this is xer, which is going to be my yer on my log. And my domain, or my range, is y is greater than 0, so the only thing, it's going to be x is greater than 0. So if my asymptote of my exponential is based on my vertical translation, what is my log going to be based off of? Horizontal translation. So if the horizontal asymptote of an exponential is based off your vertical translation, the vertical asymptote is going to be based off of your horizontal, because the only way it can move is if you move it to the right or to the left. It's going to be a very straight up and down asymptote, correct? So let's go to sketch this. So now I have a vertical asymptote at x equals 0. First off, because it's going to switch. But second off, there's no horizontal translation. This is just an x. X plus 0 I could technically put beside it, right? There's no horizontal translation. And now all my coordinates just flip. So my coordinates were -5 and 0.03. Now it's going to be 0.03 and -5. 1, 2, 3, 4, 5. So really close. Then I had -4 and 0.0625. Now it's going to be 0.0625 and -4. So really close. Then I have -3 and 0.125. Now it's going to be 0.125 and -3. Then a quarter and -2. Then a half and -1. And then 0 and 1 becomes 1 and 0, even though this is not being noticeable. Then we have 1 and 2 becomes 2 and 1. 2 and 4 becomes 4 and 2. 3 and 8 becomes 8 and 3. And we connect the graph. So my domain, the domain of this graph is x such that x is what? Greater than, not equal to 0, xer. And my range?
Y is an element of something.
Y is an element of the reals. Okay, now listen. Paying attention? What kind of asymptote is this? It's a vertical asymptote. And x equals 0. Okay? So all I can really do now is I can give you a base function. Remember with exponentials, the key to them is they have to have the same base, right? And I gave you a whole bunch of questions every single day where it would be like 2 and then a half. Then the next day I'd do 3 and a third. And then I did. And you have to just change it so they were the same base, correct? But that base was found nowhere in the question. right? Like you wouldn't say stretch, reflect, translate. The base wasn't actually stated anywhere, right? So logs are the same, except the base of the log has to be the same. So an example. Y equals log base 3 of x. Now I can add anything to the other one. I'll say it's transformed to log base 3 of x. And now I can add any translations I want to it. Correct? So I'm going to go is transformed to y equals negative 2 log base 3 of 1/2 x plus 2. That's what I'm going to do. Same rules as before. The base has to be the same. Is the base the same? Yes. Good. We're in a good boat. Same base. So we have the same base. But what do I have to always make sure I do? I have to have an x with a 1 in front. Do I currently have that?
No.
No. So I am going to go y equals negative 2 log base 3. And what do I get? 1/2 x plus 4. Remember, when you GCF out a fraction that is less than 1, your C value, because that's your C value, your B and the C, will become bigger. Correct? Bigger. Because you're dividing by 1/2, which is like multiplying by 2. All right. What are the transformations? We're not going to write them down. We're just going to talk about them. What are our transformations? Stretches first. Do we have any stretches?
Vertical.
We have a vertical stretch by a factor of 2 about the x-axis. I have a horizontal stretch by a factor of 2 about the y-axis. My horizontal stretch always flips. Okay? I have reflections. I have a reflection in the x-axis, which is lovely, but it does nothing to my graph. Well, it'll change it, but you know what I mean. And then I have a horizontal translation 4 to the 4 to the left, 4 units left. I have no idea what you said, but okay. All right. So exponential functions, horizontal asymptotes are based off of the vertical translation. We agree? That's a gift. Okay, horizontal asymptotes are based off of your vertical translation. So log graphs are vertical asymptotes. And what are they based off of? They're based off your horizontal translation. Because your vertical asymptote is normally at x equals 0. Correct? This graph has been moved 4 to the what? Left. So I actually have a vertical asymptote, horizontal translation at x equals negative 4. And my graph, my log graph, is always to the right. Correct? Unless there's a reflection in the what? Y-axis. So I know my domain, just like my range of my previous one, my domain is going to be x such that x is, if I have a positive 1/2 in front, is my inequality sign flipping? No. Greater than negative 4 XER. So that would be round bracket negative 4 to infinity. And my range?
Y is an element of the real.
Yeah. Y such that y is an element of the reals. Or negative infinity to infinity. So I'm going to get you to work on some questions. This shouldn't be a hard one to do because we know all of our translations. If you stink at translations and inverses, not so easy. But I believe in you. This is going to be page 390. Actually, I'm going to say 389. Numbers 1, 2, 5, and 6.